Welcome back to Klein's Geometry. Today we're going to look at the Pythagorean Theorem, which, as I know many of you know, is a squared plus b squared equals c squared. This is a theorem we can use on right triangles only to find a missing side length, whether that side length is one of the legs of the triangle or the hypotenuse. Consider this triangle right here. A and B are the legs of the right triangle because they form the right angle. So A and B right here, we got legs. C is the hypotenuse of the right triangle. It is across from the right angle. That's where we're going to find C. And we have to set these up right or we just mess up our work completely. Now if I want to find this hypotenuse here, it's a simple question of writing down my formula, plugging in what I know, and working it out. Notice I've got 36 plus 16 equals c squared. 36 and 16, 46, 52 equals c squared. Now when we square root this, we are interested in this course in getting exact answers. So we're going to need simplest radical form. What I'm going to do is I'm going to factor 52 into some perfect square factors. I know 4 will go into this, so I can say 4 times, and 4 goes into 5 once, 4 goes into 12 3 times. So 4 times 13 is 52. So now that's going to be c, because squaring and square rooting undo each other. Now I've got the square root of 4 times 13 here. Well, I know the square root of 4 is 2. Square root of 13 has got to be messy. So there's my c. It's 2 times the square root of 13. We're going to write these things with exact answers. Now, if you look in the next video on the Moodle, you will see a whole video on how to find things in simplest radical form. So please check that out before doing your homework. Now, let's look at this example here. I've got x and 12, and I see these are forming my right angle. So I know if I write down my formula, a squared plus b squared equals c squared, that these are the legs. So I'm going to put this in for A and this in for B. C, always across from x plus 4. So I've got x plus 4, quantity squared, always across from the right angle, excuse me. Now I need to simplify this. So I'm going to say x squared, and I know 12 squared is 144. And when you think about x plus 4 squared, you're really thinking about x plus 4 times x plus 4. So I need to FOIL this. X times x is x squared. X plus x times 4 is 4x. 4 times x is 4x. And 4 times 4 is 16. Well, 4x and 4x is 8x. So on this side, I actually have x squared plus 8x plus 16. Okay? Now, I'm not going to panic too much about this. I'm going to solve it for x, but I notice I have x squared in both sides of my equal sign. So if I take away x squared from each side, basically those cancel out. And I'm left with 144 equals 8x plus 16. Take away my 16 from both sides. Now this is a 0, and here I have to think of this is 13, and 14 minus 6 is 8. 3 minus 1 is 2. I still have 128 equals 8x. Divide by 8. And x is going to equal, well, 8 goes into 12 once with 4 left over, and 8 goes into 48 6 times. So x equals 16 in this case. There's nothing to square a square root. My squares canceled out. So I know that this leg is 16, and this is 16 plus 4, so it equals 20 units. So my hypotenuse is 20, and my leg is 16. So when we're finding these, easy enough to do. Now, let's take a minute, look at simplest radical form once again. If I want the square root of 25, well, that's simply 5. We're fine there. If I wanted the square root of 50, I might think of that as 25 times 2. Well, I know the square root of 25 is 5, so I have 5 square root of 2. If I want the square root of 80, I know, well, that's the same as 4 times 20. Well, square root of 4 is 2, so I could say equals 2 square root of 20. But I think, again, 20 is like 4 times 5. Well, square root of 4 is 2 again. So I've got 2 times square root of 5, or 4 square root of 5. And you might do some of that in your head. So you might have noticed 16 times 5. But if you didn't, you can do it in stages, just like simplifying fractions. It all works out. Square root of 90, well, I think of that as 9 times 10, because 9 is a perfect square. Square root of 9 is 3, so I have 3 square root of 10. So when you're doing simplest radical form, think about it as find a factor of our number in question that's a perfect square. 2, which would be like 4, or 3 squared is 9, 4 squared is 16, those sorts of numbers. Write your factors under your radical sign, square root what you can, and take out your perfect square. So again, look at the video, please. But that's a little short lesson on it. Now, Pythagorean triples. They're any 3 whole numbers that fit a squared plus b squared equals c squared. So you might be given something like this and say, hey, find a. Does it make a Pythagorean triple? And you would say, well, a squared plus b squared equals c squared, and you'd go a squared plus, oh, let's see, which is c? C is across from the right angle, so I'm going to put 15 squared here. And b squared must be here then. Well, I know a squared, 12 squared is 144. 15 squared is going to be 225. Now, if I take away 144 from both sides, I know a squared is 1 and 12, 81. Well, when I square root that, that is a perfect square, and a equals 9. So I would say this forms a Pythagorean triple because forms a Pythagorean triple because 9, 12, and 15 are all whole numbers. So that works. Now let's look at this one. And I think a squared plus b squared equals c squared. Well, c is right here, so I've got 8 squared plus 10 squared equals c squared. 64 plus 100 equals c squared. 164 equals c squared. Well, that's not going to work out very well. That's not a perfect square. So I would just say c is going to be square root of 164, so 8, 10, and square root of 164 do not form a Pythagorean triple because square root of 164 is not a whole number. So that's the sort of thing you're going to do for that. Now you're also going to look at some Pythagorean inequalities. And here's how this works. Let's look at our handy little, you saw this angle in the last video. Think about this as 2 sides of a triangle, and here's our third side. And you can see if this forms a right angle, a squared plus b squared equals c squared. Now what happens if this angle becomes less? Well, the length of c squared a squared plus b squared did not change, but c squared is going to be smaller. So if that third side squared is less than a squared plus b squared, you've got an acute triangle. And if you look at a squared plus b squared here and c squared, well, as this gets larger, notice c gets larger too. So as the angle gets bigger, c squared is going to be bigger. So if the third side is greater, squared is greater than a squared plus b squared, you'll have an obtuse triangle. So Pythagorean inequalities, if in the triangle ABC, always, this is key, let C be the longest side. And then if c squared is greater than a squared plus b squared, the triangle's obtuse. If it equals a squared plus b squared, it's a right triangle. And if c squared is less than a squared plus b squared, it's an acute triangle. So you'll get questions that say things like, can 8, 11, and 13 be sides of a triangle? Well, you remember that from lesson 5.5. We'll just say 11 minus 8, 11 plus 8. Does 13 fit in between? And here I've got 3, and here I've got 19. This works. So then you say, yes, the lengths make a triangle. And then we need to know, is it acute, obtuse, or right? So first thing is, find the biggest side. And then take the other two sides, 8 squared plus 11 squared, and compare it to the biggest side, c squared. Here I've got 64 plus 121, 169. Add these together. 4 and 1 is 5, 6 and 2 is 8, 185, 169. I see that this third side is less, so I'll say since c squared is less than a squared plus b squared, you have an acute triangle. Okay, so that's all you have to do here. Now, let's look at one more example just before we're done. First thing, can 7, 12, and 16 be sides of a triangle? So let's see. 12 minus 7, 12 plus 7. Does 16 fit between them? 12 minus 7, 5. 12 plus 7, 19. 16 fits there. Can they be sides of a triangle? Yes. Is it acute, obtuse, or right? Well, biggest side. So I'm going to have 16 squared here, 7 squared plus 12 squared here. 16 squared. Don't know it off the top of my head. 6 times 6 is 36. 6, 7, 8, 9, 16, 9, 256. Thank you. 49 plus 144 here. 256. 9 and 4 is 13. Carry the 1. 4 and 4 is 8, 9. 193 here. I see the third side is greater. So since c squared is greater than a squared plus b squared, the triangle is obtuse. So you can use that Pythagorean theorem idea, go a little bit further, and tell if your triangles are right, obtuse, or acute. So we just looked at how to use the Pythagorean theorem. Remember that the hypotenuse, C, is across from the right angle. We learned that a little bit about simplest radical form, and I suggested that you look on that website for a little bit more. We learned that Pythagorean triples are any whole numbers that fit the Pythagorean theorem. And then we learned that the Pythagorean inequalities, if c squared is greater than a squared plus b squared, the triangle is obtuse. If it's equal to it, it's right. And if it's less than it, it is acute. So enjoy your exercises for this section, and let me know if you need any help.